Okay, thank you everyone for joining today. Today we're going to be talking about Parasoft SOAtest and what it can do for your organization. We'll start off a little bit reviewing the business challenges you shared with us and some of the problems you're facing within your organization today. After that, I'll do a short overview of all the functionality in SOAtest so you have an idea of the breadth and depth of our solution from a high level. And from there, we'll jump straight into a live demonstration so I can show you what we've got. All right, so we've learned that your organization is adopting agile methodologies into your SDLC, and as a result, all these sprints and iterations you're working on, the time frames have shrunk dramatically, and it's put tremendous pressure on the testing organization. There's more functionality being delivered faster, and with the manual testing processes that you have today, there is a challenge in being able to keep up with that pressure and that demand. The obvious conclusion from this is that test automation is necessary to improve the processes and allow the testing organization to meet the challenge of today. Additionally, we learned that the types of issues that the organization is dealing with lately are all around integration of their systems, and as the complexity of your systems has been growing, integration and integration testing has been a bigger and bigger challenge for you. Another point that we discovered is really around performance testing, and there have been some issues with performance and production, and you're hoping to get a better handle of your performance testing, or being able to do performance testing, I should say, using a holistic solution. So Parasoft supports functional load security penetration testing. If you look here at the slide, we've got a very large breadth of protocols that are supported. Certainly not all the protocols we support. If we had a much bigger slide the size of a football stadium, we could probably fit everything we support in there. But nevertheless, here's some of the big ones we've got. So some of the APIs that I know you guys are working with, like SOAP and REST, fully supported by SOAtest. And some of those web technologies like JavaScript and AJAX in your web environments are also supported. So just to give a brief rundown of the functionality, SOAtest supports end-to-end testing, and what we mean by end-to-end testing is not just the ability to automate the testing of your web interfaces, but also going deeper, being able to automate the testing of your APIs and other downstream systems. So taking this end-to-end approach and being able to validate all the affected systems when you go through your use cases. Service virtualization is another area that Parasoft helps organizations with around emulating application behavior. And these are two areas that I'll get into a little more detail in the next slide. Performance testing is another key component. Integration with any test management solutions that you may have, like HP's ALM or Parasoft Concerto. Also security penetration testing, compliance verification. And of course, last but not least, manual testing of APIs. Right? APIs don't have a GUI. We can help you test them. And the key point here is that this really broad set of functionality that we offer is really delivered in a uniform and consistent manner. So you're not piecemealing many different solutions and trying to cobble something together to really meet the testing demand of what you have. We have a one-stop shop here, and as a result, you see much better process and better efficiency by doing so. So last slide, I promise, and then we'll jump straight into the product. But I just want to, a picture does a much better job explaining it than words do. So I want to briefly kind of introduce a simple end-tier application here. And here we've got, right, the web layer. There's a web services layer where there could be mobile devices and mobile applications connecting to your system, third parties. As part of your system here in this central box, there might be connectivity to business partners where they provide services that your application depends on for its functionality. Or even, right, with today's growing disparate systems and distributed systems, you might also have internal applications that are in separate groups that your application needs to communicate with. So ultimately, in this complex world of many distributed systems and many technologies, the testing of these systems is paramount. Where Parasoft fits in is first being able to automate at the UI level, so helping you improve the efficiency of your UI testing through SOAtest. And also, we know that with enterprise services, and again, these distributed systems, testing the APIs directly is crucial. Right? If there's problems with the API, it can have a cascading effect of software failure across many, many systems in your organization. And as a result, the quality of those APIs is critical. Furthermore, with Virtualize, we can help you isolate your application under test from its dependencies. So when you have problems around environment access, environment constraints, test data management problems, performance testing constraints, Virtualize can play a key role in assisting you. And then when we get to the complexities associated with systems that have asynchronous messaging, notifications, and downstream systems being affected, SOAtest can go in and validate those downstream systems and asynchronous messaging flows to really ensure that you're testing your use cases throughout the application stack. And lastly, if you've got enterprise service bus that's managing your middleware, SOAtest also has special support for gaining visibility into those ESBs and helping you automate the testing of them. So, without further ado, why don't we actually jump into SOAtest and take a look at what we can do for you. So I'll give you a very brief tour of the UI so you're familiar with what I'm doing and can follow along. Here on the left is the Test Case Explorer. This is where the QA engineer would be able to create and manage all their test cases. So one key aspect of SOAtest is its ability to scale in the amount of testing that your team can do. Right? It's really designed around sharing of test assets, organizing test assets in easy-to-consume ways, and being able to meet that demand of increased testing, increased complexity of your application without losing the efficiency of just throwing bodies at the problem. Here in the middle, this is where I'm going to be editing things and changing configuration. Bottom right is progress as we're executing tests. Bottom left is where I see some test failures that may arise as I go through my testing. And what I'm going to do first and foremost is I'm going to be testing a web application here called Parabank. So let me quickly show you what Parabank is. It's very similar to that N-tier application from the slides. It's got a web interface. It's got web services that sit behind it. It's got a database. So there are many disparate components to Parabank that are all connected together. And what we're going to see is how SOAtest can support not just testing these different systems in isolation, but how we can really build an end-to-end scenario that traverses through the technology stack. So I'll copy this starting URL here for Parabank. And what we're going to do is create a new project from web browser recording. And let's call it Demo End-to-End for our partners. And what we'll do is paste in the URL. I'll create the name of the use case that I want to be recording. Parasoft supports IE, Firefox, and Chrome. One of the great things about this is if I record in IE, I can play back in any of the other browsers. So I'm not tied to a specific browser based on what I do my recording from. Its maintainability report, I'll come back to that after we create our test. And environments here are basically going to allow us to easily reuse the test cases we create across different environments in your organization. So when we're talking about reusability with the automated tests you're creating, you can go from you've created an automated test in the QA environment, and you need to rerun that test when that build gets promoted to the staging environment. There's very little work involved to reuse those tests and revalidate that the build in staging is successful without any errors. So a lot of opportunities for reusability. So what I'll do is the current environment we're in is local dev environment, yeah, and we're testing Parabank. So what's happening is SOAtest is going to launch Internet Explorer, take me to Parabank, and I'm going to go through my scenario here. And what we're going to do with our scenario is I'm going to log in, and I'm going to create a new account. So John, demo, log in. And this, as you might expect, bank has many different operations, right? I can transfer funds, pay bills, request loans, or open a new account, in which case this is what I'll be doing. So let's go through, open our account, and congratulations, account opened. Now that this account has been opened, I'm going to go to my accounts overview, because what I want to make sure is out of all the accounts I have as a customer, when I've created my new account, I want to make sure that the total balance here hasn't changed, right? Because I'm taking money from one account and I'm using it to open a new account, so there's no real plus or minus in terms of the total balance of all my accounts. So that's something we're going to check for and make sure that that truly happens. And at this point, we'll log out and close the browser. And what we're going to see here is SOAtest has created our project for us and created this test maintainability report. And what the test maintainability report does is twofold. One, gives us a quick rundown of what we recorded and what steps we took for our web playback. And the other thing is it highlights if there are any issues with with what we're using to uniquely identify certain elements on the web page. So the way SOAtest works with its web testing is, let's say we want to click that login button. So let's go take a look at that. The way we're clicking this login button is by uniquely identifying that button from the HTML DOM. And it's actually web development best practices for there to be unique identifiers on all these objects on a web page. So if we look, we don't have any test maintainability problems. So basically, Parabank has unique identifiers for all the objects on the page. If there weren't, or if there wasn't a unique identifier, SOAtest would use XPath to locate that element, and we'd still be able to play back. But XPath can be brittle to structural changes to your page. So if the button moves cosmetically from one area to another area, that would be a maintainability issue. And the fantastic thing about this report is this is something that you can package and send to your web developers and tell them, hey, you guys aren't following web development best practices. If you want to really improve our team's ability to quickly test the pages that you're building, give us some unique IDs on these objects that don't have any, so we can quickly go through and build robust and maintainable test scripts. Now, XPath is a very powerful language, so even if developers fight you on this, you can build robust XPaths to intelligently locate elements even if they move structurally. So there are ways around working with development on that. The next thing I want to point out is really around our ease of use when it comes to web testing. So unlike many of our competitors you may be looking at, with SOAtest, we're really a scriptless GUI interface. So you don't have to learn some proprietary scripting language to be able to automate your web testing with Parasoft. So if we look here, we've got a browser rendering of the web page before I perform that login action. And if you notice, we're highlighting in blue what we're doing in this particular part of the flow. And if you look here in the User Action tab, this is essentially the configuration of what we're doing. So we support all the common actions that you might want to do in a browser: click, type, double-click, all that good stuff. And we've got some unique IDs. In this case, the login button has an ID for login, so we can uniquely identify it on the page. And beyond that, we've also got wait conditions that we've automatically configured during the recording. And these wait conditions become very important when you start looking at AJAX and asynchronous calls that the web page is doing with the server. So a great example of this is, think about the Facebook news feed, right? All you do is you move your mouse around and Facebook updates, right? But you didn't hit F5 to reload the page. There's just asynchronous traffic going on in the background between the browser and the web application server. So how can we automatically figure out how long we should wait before we should move on to the next step in our recording? So Parasoft fully supports these asynchronous flows by capturing what our wait conditions need to be, and if there's asynchronous traffic going on, we add additional wait conditions to make sure that asynchronous traffic ceases before moving on to the next step. All right, so we've got our recording here. We've covered the basics of how the support works. Let's play back and see SOAtest in action here. So, right, That's all there was to it, really. I recorded my steps, I went through everything, and SOAtest is playing back my recording just fine. However, this isn't really, we're not really testing anything at this point. All we're testing is the ability to click through all the pages, but we're not really validating anything yet. So what I want to do is jump in and show you some of that. And where we can do that is, firstly, we can take a look at the post-action browser content, which shows us what the web page looks like after I perform my action. Right? So here, this is after I click login, and sure enough, it takes me to my account overview page after logging in. So maybe one of the things I want to check is I want to check and make sure that Welcome John Smith gets displayed there when I log in as my John account. So all I need to do is right-click, right, extract that element, and what it's doing is it's giving us a view of the HTML that we've selected from the page and tells us what we want to extract. So in this case, the text John Smith. We can even, so if there's a paragraph of text and you're only interested in certain portions of it for your extraction or validation, we can isolate that using left and right hand boundaries. So for example, if I type John, you can notice right now it's only going to extract Smith, right? Or if I do Smith, right, it only extracts John. So we can even do that. And here is basically what we want to do. Do we want to validate John Smith upon playback, or do we want to extract that John Smith text and use it in a later test? So we have our options. What I want to do is validate that it's equal to John Smith. And then you notice it highlights in red what we're validating. And we've got this browser validation tool that I'm going to show you real quick. It tells us, okay, if the test fails here, what is our custom error message that we can go configure? I'm going to call this John Schmuck. And when we play this back, we can see the failure happening in action here. But before we do that, I want to cover one more topic, which is, at this point, we're only using fixed data values, right? It's logging in only as John Smith. So what I want to do is, oftentimes, and especially in QA, we need to run through many different conditions. So what we can do is Parasoft supports data sources where we can take test data from CSV, Excel, even pull data directly from a database and use that to drive our test inputs and expected outputs. I'll use our built-in spreadsheet, and I'll call it Parabank Data, and username, password. So we'll do John Demo, and then Parasoft Demo. So we've got our test data, and as far as connecting my test data to my test, very, very easy. Just go to my test. Here's my user action where I'm typing John. All I need to do is switch that to parameterized. Got my username, and it's got nice little usability things like autocomplete. As I start typing something, it'll complete for me. And that's it. I've configured my username and password to go to my spreadsheet. We've got our validation there looking for John Schmuck. Let's play this back, and what we're going to see is Internet Explorer first going through John Demo, and we've got our recording here. We'll be seeing some failures after this playback occurs. Open a new account. Once this is done, it's going to log back in, and this time it's going to log in as Parasoft Demo and go through the same set of steps, right, that we had with our recording. And it really is that easy, right? I don't have to be a developer. I don't have to know some proprietary scripting language. Parasoft really allows you to go in and automate your web testing very quickly and very easily. So if we come take a look at SOAtest, sure enough, we've got 2 test failures here. And what we see is for both data source rows 1 and 2, first one was John Smith instead of John Schmuck. The second one was Bob Parasoft instead of John Schmuck. And we've got all the details we would need for that test failure. So we're good to go with that. Next, what I really want to cover is taking this example and blowing it out into an end-to-end context. All right? So what we've really covered so far is just web testing. Right? But as you remember from the example, Parabank also has APIs that drive the data coming to the web page, and it also has a database. So as I'm going through this this test case, there's deeper levels of validation I can do to make sure that we're not missing any errors that might exist. So we've got my create account scenario here. What I'm going to do is add a new test suite here. And we're going to consume the Parabank WSDL. So let me make sure I'm selecting the right one. So SOAtest also supports APIs and API testing. So as we can see, the Parabank WSDL has a whole bunch of operations that support the bank's functionality, right? Do a deposit, get accounts, transfer money, withdraw money, all the stuff that you have with a bank. And what we want to do is we're going to expand this out and make a cool little scenario. So I'm going to add an empty test suite, and let's call this validate deposit. So with my validate deposit scenario, what I want to do is first get an account. So I'll copy paste, put that in, and then I want to do a deposit transaction, and then get account again to make sure that after I do my deposit, the right thing happened to that account. So I just used this as my template of the possible operations, and I'm putting together the scenario I want. Notice how easy that was, right? Copy, paste, drag, drop, all that stuff. It makes it very easy to build the kind of complex scenarios that I need to do to test the requirements, to test the user stories and functionality that I need. Now here's where it's going to get really exciting. The account that I'm going to use is going to be the account I created from my web test. And if we go back to our web scenario here, remember we create an account, and when we look at this create account step, right, it says, congratulations, your account is open, here's your new account number. So this is a dynamic account number that gets generated from the web page. So let's highlight this, extract this text, and I'm going to call this new account number. And it highlights in gray things that I'm extracting. So I've got my new account number, and guess what? That new account number I extracted is the account number I'm putting into my SOAP request. So we're going beyond the normal bounds or boundaries of testing, where traditionally it's just web, just APIs in isolation. we can actually build a true end-to-end scenario that goes from web, go validate the API layer, and as we're going to see later on, go directly to the database and check the database too. So we've got our account number here. And if we take a look at deposit, it also takes an account ID, so we'll use that new account number and an amount. And let's deposit $100 here. And our last one, we want to use that same account number again. So we've configured my web service requests appropriately. Again, when we come to API testing, you notice I'm just filling out a form here. And I'm quickly connecting it to data either from a spreadsheet or dynamically extracted from another test. Again, there's no scripting. I'm not a developer here. So I can very easily build this kind of complex scenario without very much effort. All right. So I'm going to switch my data source here back to just one row to make our playback a little faster. And what we're going to go through is our end-to-end flow up until this point. We're going to go, log in, create a new account, take that account number, jump into our web services API, and start doing some web services transactions and validating the API layer as well. So if we take a look, right, we've got a failure with our validation. John Smith is not John Schmuck. So let me just go in there, make this John Smith again so we don't see that failure anymore. But let's do one thing. Here we see, oops, wrong one. So here we can see the account number was 15009. So let's take a look at get account. And sure enough, in the request, we put in 15009. It was that easy. We didn't even have to write a single line of code. And if we take a look from our web service response, it gives us data on that account. Notice the balance is $100. Great. And I've got this element view here, strips out all the XML, makes it very easy for me to come in, quickly see the data I'm working with. With our deposit, all right, we can see the response came back. We successfully deposited $100. And then now when we do get account again after a deposit, sure enough, it went from $100 to $200. Great. So now you might be asking yourself, okay, so we've got $100, we do the deposit, we check, now it's $200. How do I automate this? Right? You just showed it to me manually. Well, let's take a look a little deeper into our API support. So what I really want to do is I want to extract that $100 from my first get account operation and compare it when I do get account a second time and make sure that it got incremented correctly. So the first thing is, let's extract that $100. So we do get account. SOAtest makes it very easy for me, where I just need to come in and it gives me a tree view of the response, and the balance is right there. That's what I want to extract. And let's give this a better name than test1 balance. We can call it original balance. And now what I want to do is I want to take this original balance and compare it against the new balance after my deposit. So I come in, let's go here, and instead of a data bank, now I want to do an asserter, some sort of validation. So notice how easy it is to expand on the tests you're doing and do more things in a very intuitive and logical way. Right? SOAtest has all these tools that have certain functions, and I can chain them together to do complex things. So here in my asserter, and just to give you an idea about just how powerful this asserter is, let's expand this and really take a look. I've got numeric assertions, string comparison, regular expressions. I can even write a custom script. So while this GUI scriptless GUI interface is great, you can still do scripting if you need to. 99% of the time, everything you'd want to do, we support out of the box. But anything custom that requires some scripting here and there, you'll have an out. You're not tied or locked in to our GUI. We can even really build complexity with our assertions, right? If account ID is 123, check this. If it's something else, check that. So we can really go nuts with our assertions. And what I'm interested in is the difference assertion, a numeric difference, right? Because we're doing a deposit. So I select balance from my tree. And what this assertion does is say, okay, the base value, right, that's going to be my original balance. And that needs to be different by $100. And that's my difference value, all right? So check deposit worked. So I've got my validation set up there. All right. So let's take a look and see what happens when we do this playback. And again, we're going end to end, and we're going to be going even deeper down the rabbit hole after this. All right, so we've created yet another new account. And we come into SOAtest. Once the web tests are done, all the web service tests completed. And sure enough, 15120, that new account was used. Our asserter passed, right, because it's correct. The balance did update correctly. Now, we're going to do one more step. Let's go directly to the database. So I'm just adding test suites here to organize things easily. So as a tester, when I come back a couple weeks later and I'm looking at this test, it's very clear to me what the test is doing, and I'm organizing things properly. And here with our DB tool, I basically just need to provide the connection string to connect to my database and my SQL query. So let me jump in and remind myself what the connection string for our database is. Okay. And this is something that testers will often do manually, right? They want to manually go in and make sure that the database has the right data after they're manually testing the UI or an API. And what I want to do is, my SQL query is going to be, I'm going to select the balance from an account where the ID, again, is that new ID that we extracted from the web page. Right, so there's my SQL query. And let's make sure that I'm using the right syntax. This time I called it new account number. So call it new account number. And that's it. Now let's play this sucker back and see what we get at the database level. So while this is playing back, let's think about this for a minute. In the order of about 10 minutes, I've automated a use case that creates a new account on the web page, validates that the account balance is correct from an API. We even do a deposit via the API to this new account, right? Validate that deposit worked correctly. And now we're also going to the database where the data ultimately ends up to make sure that the data in the database got updated properly. So if we think about this, this scenario could represent, all right, we've got our web application that displays the functionality to create new accounts. Right? After that account got created, an external system like an ATM came in and they did a deposit to this new account that they created, and that happens via the APIs. So we make sure that, yeah, sure enough, when APIs get involved after creating the new account from the web page, that worked properly. But it's a very complex environment. We also need to make sure that the data ends up ultimately in the database. It's not cached somewhere where we can have subtle caching issues that might arise. So we definitely need to check our database so we can see we've got this balance 200 coming back. And you might ask yourself, well, I mean, how do I automate checking this? SOAtest makes that very easy for us too. SOAtest is going to serialize that result set as XML. So just like how I was validating the API, I can validate the database exactly the same way. Pick my XML asserter, and what I want to do with my asserter is come in and say numeric assertion, right, because it's balance. Select balance, and I want it to be equal to $200. And let's call this validate balance in database. All right. However, I want to extract that $200 from my updated get account. So not only can I extract data from a web page, I can just as easily extract data from a web service. So come in, got my data bank, right? I can call this new balance. And then I come in here and I want to say the database needs to contain the new balance. Done. So now I've really got my whole end-to-end flow. And when I test my application, I'm going from the web layer to the API layer to the database layer, all very intuitively in a matter of minutes, and I didn't write a single line of code to do that. And we'll see this go through to completion. So this kind of wraps up, from a functional testing perspective, really the breadth and power that SOAtest can give your organization when you're trying to automate this integration level testing where you're finding a lot of problems with your complex environment. You're going to be hard-pressed to find anything that's going to do it for you as easily as you can see here. But you also mentioned performance testing is another key concern of yours. You want to be able to performance test your applications earlier in the cycle and make sure that your SLAs are being met. And one of the nice things about Parasoft here is the functional tests that QA creates, these scenarios that chain tools together and they represent complex use cases. These scenarios can be reused in load test without any rework or customization or scripting. So the great thing about this is you're moving from a workflow of teams that are siloed and they're speaking different languages, they're using different tool sets. When QA does their functional testing and they're done, and the performance team needs to come in and do their performance testing, the performance team starts from scratch. They have to recreate the environments in their performance testing tool. So that's a big waste of time. If we could reuse the test assets that QA already created for their functional testing into our performance tests, we're cutting days of time off of the turnaround that the performance team can provide to development. So why don't we take a look at that? So here in load test, as I was saying, we support load testing SOAtest test files that we've been creating. We can also run JUnit runnable components if you want to load test some other components more at the code level. And what I'm going to do is I'm going to come in and find a test that I'd like to run. So let's call this Parabank load test file that I've got. It gives me an option of selecting which scenarios I want to load test. So in this case, what I want to do is I'll pick some web service. I'll pick some web service transactions here that I want to be load testing. And essentially what that choice did is I'm creating different user profiles that do different types of transactions, and I'm going to be specifying how much load each of those user profiles is going to be driving. Now, next step in this wizard, I'll control the number of users. I can also have control it by hits per second and so on. And let's make this just a 1-minute load test. There's different levels of distribution here. This is completely configurable. It's just part of the wizard, what I might want to do. Linear increase is fantastic for finding the breaking point of your application, right? Keep increasing the load and increasing it until things go wrong. Steady load is perfect when it comes to validating SLA, right? The business says we have to support 50 concurrent users, so we can validate that, yeah, the application can support 50 concurrent users. And there's all kinds of other cool stuff that the wizard does, like, all right, testing for, highs and lows as far as transactions throughout the day, buffer testing, right? How does the application handle memory allocation, deallocation when we slam the system all at once? A lot of cool stuff just from our wizard here. We also support monitoring back-end systems. So not only do we load test, or put your application under load, but we can start monitoring your back-end application servers and seeing how they're handling memory consumption, CPU usage. Are there any bottlenecks of your back-end systems as we're driving the application through load? Quality of service metrics I'll get to in a second. And another nice thing about our solution is it's completely scalable. So if you have really high load testing requirements, you can deploy load tests onto the cloud and have a bunch of machines spin up and use those machines as driving additional traffic to your application. So let's say you wanted to set up a load test where you're using a partner like EC2 or someone else that provides cloud access to distributed systems around the world. You could spin up a machine in Hong Kong and a machine in Europe, machine in New York and Los Angeles, use those machines to drive load into your data centers and start testing and making sure that your application is meeting your SLAs worldwide. So last but not least, we're going to specify what we want to capture during our load test, and we'll see some more of that stuff as we go through. But that wizard created everything we wanted very, very quickly. We can see the different user profiles here based on the SOAtest tests, right? What we're going to be executing concurrently. We can add various different think times there. Now when it comes to our actual scenario, this is where it gets pretty cool. So that linear increase, as I was saying, this is completely customizable. Whoops, I could come in, I could add points, really configure the profile of my load test the way I want it to be. And here, we can use weighted profiles to control the distribution. So here's the maximum pool of users we have available as the load test completes. And here is our distribution of users, right? So what I'm saying is my withdraw transaction is going to be about 50% of the overall transactions. And I could add points here and customize this as well. And I can really have load test figure out how to distribute the load across these different user profiles to meet these different ratios. So a really fantastic way of simulating real production level conditions where you know already how much of a certain user type is hitting production. We can also directly assign virtual users to profiles if you want to do that. You're not tied to weighted profiles, but it's very nice. So because I don't have, actually I do have access to Parabank. So what we're going to do is I'm going to select a specific process on my machine. Let's see. And what I'm interested in is processor time, and I'm interested in memory. Okay. So let's see, which one should we select? Okay, so we've selected some things that we want to monitor, and we can see that we're actually monitoring the server and how much CPU and memory utilization is happening. So this happens to be our Parabank server that's running in the background right now. Let's fire this guy off and see what we get. And here what we have is real-time metrics on how our load test is progressing. We can see virtual users are climbing, right? Our throughput here, our hits per second, is climbing rapidly as well. As far as execution time, we've got some pretty big discrepancies between average and max. So there are some transactions here that are really abnormal compared to the average. I can change this to logarithmic scale, so I can get a much better sense of the different graphs here that we're capturing. Right, I can see more graphs, split them up and look at them individually. Right, do I want to see the CPU usage? Right, so CPU is cranking around 20–30%, and we can see how my server was doing memory. But that was just a 1-minute test, so I didn't finish everything there. Now we've got the report, the fun part. QoS metrics here is basically your SLA. This is where you specify what the expectations of your application are, and load tests will check that data and make sure that your SLA is being met. Right? So we've got some QoS metrics here that we can specify for your hit rate, your throughput, stuff for any test failures, things around average server time, average execution time. And you notice here the actual results, most of them fell in very well, but we had a bunch of test failures. I happen to know that Parabank has some serious concurrency issues when I run it through load testing. So it's not designed for dealing with a lot of load. So we're seeing a lot of test failures occur there. Load test provides not just a wealth of statistics on your execution times and run counts and things, but it's hierarchical. So if you're interested in what the performance is for a higher level scenario and what the average execution time is of multiple transactions within that use case, we bubble up the statistics so you can validate your SLA on a higher transaction level basis. And we've got access to that report. It can be filtered the way we want it to be. We can filter it to specific profiles, specific machines, right? So if you wanted to see performance in Hong Kong versus New York versus LA, you could filter the results there. And what I usually do here is I capture some of these graphs for the report that we generate at the end. And so you can kind of think of this as your report configuration and your detailed report view. Right, so here, this one, maybe I want to fill in the graph areas too. And this one, we can call this execution time. And definitely, I'm also interested in virtual users and the CPU utilization of Parabank as virtual users. And let's not fill in graph there. Okay, so, and I could keep going on creating more graphs and more views there. We also have a histogram that helps you understand where the bulk of transactions were taking place. So we can add this to the report. So I'm adding all these things to the report, and you'll see why in a second. I can actually even drill down to recorded error details, right? So here we're seeing actual details, SOAP fault coming from the server, and even associated traffic of my API call to find out exactly why the test was failing, right? In this case, Parabank can't handle the load, right? So it's throwing SOAP faults in. We can capture a lot of data here. Obviously, there's a danger with how much data you capture. You don't want to have gigabytes and gigabytes of report data because, right, we're sending thousands, if not millions of transactions. But load test gives you the access to do deeper level analysis and debugging, even getting into traffic and test failures. Right, QoS metrics we talked about. One last thing I want to also show, we can also capture individual hits here. So if we have this outlier of this one test failure, we can see, okay, what test was it, what data source row, what was the exact system time when that test ran, right? Why did that one take 1.2 seconds when everything else took 20 milliseconds? Was there some sort of garbage collection going on at that time? Can the developers compare this with their server logs to really figure out why? But ultimately, all the data is available. We can actually collect all this data. And if we take a look, the reason we configure that report is not so that every time you want to go look at your load test result, you have to open up the load test GUI, but we can generate a very nice HTML report for you here that covers everything you want to display for your report. This is something that can be automated as part of your continuous integration. This report can be emailed out to managers or engineers or leads, whoever it needs to be, and you can start getting consistent load testing integrated into your process early in the cycle. So now you might be asking yourself, man, Wilhelm must be done. But I am saving the best for last. load test also gives you the ability to do baseline comparisons of multiple load test reports. Because the most important thing to do is actually compare if performance is improving or degrading. Right? So typically what happens is you've got your baseline load test from March or April or what have you, and development is doing performance improvements and optimizations. You want to run the same load test again and see if performance actually improved or not. So our composite report makes that super easy, and we can come in and see very quickly how the performance was impacted between multiple different runs and baselines. And just like what I showed you earlier, you can export this to an HTML report, have these composites sent out to the appropriate parties. But ultimately, it's going to be a very powerful tool to allow you to really integrate your load testing into a process and really capture these performance metrics early on. So I know we ran a little bit over on time. I appreciate you guys taking the time to really sit through and see how Parasoft can help you with this complex problem that you've come to us with. And do you have any questions?
Yes.
All right.
You can use this also for word or for penetration testing, right?
Yes. SOAtest supports penetration testing also.
And for doing that kind of tests, the test cases are preloaded, or how do you handle them?
Yeah. Yes, they are. So, conceptually,
I would show it the software because it's going to make more sense to show it when we do a language slide. We have to plug in the runtime error section. So we'll explode that out.
Yeah, that's a good idea. So we can do another demo that attacks that question.
Security configurations.
Yeah.
Configurations with that.
Yeah, we have another demo that attacks security very thoroughly. But just to give you a little teaser about what SOAtest can do with penetration testing, I'll show you some stuff.
Should be underbuilt in.
Right.
Oh, no, I meant the, no.
Yeah. So, right, for XML-specific penetration testing, XML bombs, invalid schema, large XML documents, malformed XML. So we've got all kinds of scenarios here. Also attack scenarios that are applicable both for web and web services. So sending these types of invalid parameters through your web interfaces, your web forms. These are also configurable and extensible. So if you have additional penetration scenarios that your security team has built up over time for their penetration testing, you can add those into what SOAtest runs as part of its portfolio as well.
So from a sales perspective, without digging into the weeds, because I'm not a technical guy, if I understood what I just saw here in this demo, is I saw a web application that we tested its functionality.
Yeah.
We tested its API and that same functionality. We also were able to test the third-party connection to a database and validate that to get reported. And then we were able to also do a load test on that same application and have reports that can be provided to us via HTML with notifications, as well as baseline those reports and compare them. Yeah, that's what I saw. Wow.
Yeah.
Oh, cool.
I mentioned that the initial parts were all automated.
Yep.
Yeah. Automate everything.
Everything. Automate everything. Excellent.
We take this on MasterCard, yeah. And American Express.
No,
Oh, no? No, we
Oh,
don't.
They
So-
stopped paying me.
So let me ask you one other question if I can. So this, of course, is all based on web applications, APIs, and all things. So for executable applications, like, this is an executable app. How do we test our stuff then? Or does SOAtest only work just for web services and web applications? And what do we use for testing?
Well,
Desktop apps. There's plenty of those out there.
for desktop apps, we we test them at the language level. So usually desktop apps, they're built off of .NET or C++, and that's where .test and C++ tests come into play and help the developers automate their quality practices, unit testing, code review, static analysis, those kinds of things.
And then I remember talking to Joe, so I like that playback before feature, which is how that works. But that doesn't work then on the desktop application. Right? The GUI,
No.
to test the GUI.
Well, I mean, you want to break it up. Yeah. It doesn't.
Okay. So we don't support desktop applications as big clients for recorded playback.
I get.
You guys look like you absorbed a lot of
Reset button tomorrow.